Hello and welcome to Math 3150. This is our introduction, and the class is Partial Differential Equations for Engineers. So what is a PDE? So we call a partial differential equation, we'll always abbreviate as PDE. And a partial differential equation, more or less is just an equation where it involves partial derivatives. So for instance, here's one. So the idea is there's partial derivatives. Okay, and the point here is that what we're going to do, the basic goal is to model a phenomenon in space-time. That is, we usually have an x variable and a t variable, or a y variable, and so forth, even a z. It depends. But the idea is that there's some spatial system that we're dealing with, and also how things are evolving in time. So that's the big goal, is that it's like how do things in space evolve in time. And so, of course, we can also talk about things that are evolving only in space, where space might have multiple dimensions. For instance, there's the Laplace equation, another PDE we have, which we'll study a little later, but there's also so that's an equation that doesn't involve time, but does involve two space variables, x and y. So these are the two examples of PDEs that we'll be studying this semester. But the idea is that a lot of times when there's interactions between things that happen spatially and not, you get things like this. So let's focus in a little bit more carefully. So again, we're concerned with solutions to PDEs are space-time like, so they're going to be multivariate functions, right? So for instance, we have u of x of t, and the idea here is usually we actually have to write this now as a multidimensional function. So I'm just going to draw a little picture here where this is our x variable, and then we have time going forward. And so say we have some sort of some sort of initial at time equals 0, we have some initial distribution of stuff. So this instance, for instance, we might want to think of this as a mass density. And the question that's really relevant here is, like, how does we want to look at mass transport. How does mass move? Does it go this way? Does it go that way? Does mass transport through this medium in some way that's interesting? So as we go forward, so the solution of a PDE will involve both x and t, so it actually forms a surface like this. Maybe it goes out like that, and so on and so forth. And so it makes some sort of surface like that. Okay. All right, so that's the idea. So that's mass transport. And that's a central question we'll be answering, is how to model mass transport, or some sort of quantity where u could be some sort of density. So, and that could be mass, or it could be energy, or it could be, a position of some sort of quantity, and so on and so forth, like that. All right, so things involving space-time. So it's really about this idea of transport, and that entails motion. And so what are the mathematical tools we have for dealing with transport and motion? Well, when we're talking about multiple dimensions, and we're talking about motion, the tools is going to be vectors. and vector calculus. Okay, so vector calculus is something you've learned in maybe your Calc 3 class, and that might have been a little while ago. So we might want to spend. Before we dive right into PDEs in this class, what we really want to do is just do a quick review. So we're going to do a review of vectors and vector calculus, because we want to just reactivate some of your memories of your knowledge of vector calculus, which is really going to aid in how we model the underlying physical processes that create partial differential equations. So in the next couple of videos, we'll do some review, and that'll start us off on our course in the right way. Thank you very much.